Hello grade 12s. Today I am looking at the 2020 IEB final paper 2, and I'm going to be working through some of the questions here. Again, if we just take a look at what they've asked in the breakdown here, you see we've got a mechanical analytical for 20 marks. We've got the LOCI CAM only for 40 marks. So there's no split here, there's no mechanism and cam drawing, only a cam. There is an isometric and a mechanical assembly. So let's get ready to take a look at the mechanical analytical for 20 marks. Again, what is interesting with the mechanical analytical is that the mechanical analytical has got questions on the same component that has been used in the mechanical assembly question 4. So I think it's maybe a nice way that they're getting you to get used to seeing the diagram here, and then that could help you in the mechanical assembly drawing. Anyway, when we go through this, you should have covered the reading aspect in your reading time before the exam starts. Try and read this last before the reading time ends, so that as you finished reading time, you've already got this information clear in your mind and you're able to get started with this. So what I've mentioned to you before, we've got our title block. If there is any written information in the title block, be very aware of that. Here, all unspecified radii are 5, tolerances on all dimensions plus minus 0.25. Okay, they often like to ask questions about that, so just keep that in mind. There's your parts list, different parts, the quantity and the material that they're made from. Again, we have got a comprehension type of mechanical analytical where they're asking questions and you need to provide answers. They've included the projection symbol, which is something different for the IEB. That usually comes up in question 4. Now, spend some time, please, again, just reading through the questions, looking at the different diagrams and trying to make out some of the information there. Hopefully you have got your notes and you have covered your machining symbol and your welding symbol. As we get started with our questions, I'm answering my questions in pencil and in capital printing. So question 1, we've gone over reading the information here, and the tolerance is plus minus 0.25. What material was used for the sphere? We come to our parts list here. There is the sphere. It is stainless steel. Name the type of sectioning in part A. Here is part A. They've cut this part off, so it's not going all the way through the shape, it's cutting this off. Now remember, full section implies half of the shape has been cut away. Here, a quarter of the shape has been cut away, which is meaning that this is a half section. So a half section when a quarter of the shape has been cut away. What is the total height of part A? So here are your different measurements, you just need to add them up. So 14 plus 62 plus 62 plus 14. Give you a few seconds to add that all up. And that should give you your answer of 152. What is the feature 1 in part A? Here is this feature. This is the correlation between your understanding of paper 1, which is showing how this narrow pipe is fitting into the bigger pipe. Okay, so this is the bigger pipe, here was the smaller pipe, and it creates a funny shape where they join each other, which is called the curve of interpenetration. The curve of interpenetration. What is the radius of the fillets in part A? Now, part A, there is the fillet. Remember, when we've got a horizontal component and a vertical component, that gets that little curve. Now, the dimension isn't shown here, which means we go back to the information in the title block where it says unspecified radii or radii of 5. Number 7, this question has come up before. Pitch circle diameter. What is the feature 2 in part B? Here is part B. So this is where they've cut, and the hidden detail is showing that that is slightly below the surface. So when you're putting something down with straight sides, it's implying that maybe your bolt is going to fit a little bit lower on the surface of the shape. Or maybe the washer. Is there a washer? No, a washer could fit in there. So that is called a spot face, when they've cut out a small circular hole on top of another hole. In feature 3, part C, here we have got the crisscross pattern that you would see on a dumbbell in the gym, or a barbell maybe in the gym, where they put that pattern on metal, and that is for better grip. That is known as diamond knurling. Diamond knurling. Calculate the exact dimension of part 4. So here, as soon as they're asking dimension, it's testing to see, do you know your formula? So here they're asking you, what is the thickness of this washer? Now, the thickness of the washer is 0.2 times the M value, or the diameter there. So 0.2 times 14. So that would give you your measurement of 2.8. What is the direction of the spring? So here we see the spring, and it is going in this direction. So if we are holding onto your pencil, can you see that where my index finger is pointing is up towards the right hand side? So what that means is it's a right hand thread. Now if you've got a right hand thread, it means we're holding with the right hand, and we would be turning that shape, which is going to give us a clockwise direction. So I'm not quite sure what they're asking here, but it is a right hand thread, and direction that it turns would be clockwise. Okay, now these very important, your machining symbol and your welding symbol. These are aspects that you've got to really study and make sure that you know what is going on there. Okay, the direction of lay is always positioned on the inside here, so it's the C, and when you go to C, C stands for circular, so the pattern and direction of the lay is circular. The production method, so the production method is always on the top here, and it is plating. You don't have to understand what plating really means, just understand that this is the production method and give that answer. Okay, what is the roughness value? This is the roughness value, there is N12. Okay, the welding symbol. Okay, so what process does it Okay, so process is implying how is the welding done, and this is always put inside the tail here, and that is hence the answer, arc welding. Okay, and what welding types? So these two symbols, we've had this one before quite often, that isosceles triangle is always a fillet weld, and this weld is a bevel weld. As a sidebar, the other information here, the dark circle, weld on site, outer circle, weld all around. Okay, the projection symbol. The projection symbol is for third angle. We're using third angle, and the projection symbol is always the tapered roller and the circles. Now the tapered roller is like the end of my pencil if I had to cut it off, so it's tapering, it's narrow at the tip and gets bigger. So we've got to do the same thing here. It's narrow, so I'm going to draw a narrow line on this side, leave a bit of a space, draw a longer line on the other side, join up the edge and join up the edge. Now when we draw the circle, we try to have the circle on the left hand side, because the tapered roller is always the front view. Third angle, the left view is on the left of the shape. So when I draw my circle, I try and line up my circle with this line. There is that circle, needs to be a bit bigger. Now we've got the horizontal center line, and we then need to include the vertical center line. Okay, there are our answers for the IEB 2020 mechanical analytical question for paper 2. I hope you did well. Hello grade 12s. Today I am looking at the IEB 2020 paper 2. I'm on question 2, the LOCI, and they've only given us a question 2. There's no 2.1 or 2.2. It is only the CAM drawing, and hence the mark allocation is 40 marks. So with that, I would expect them to ask all three different types of motion. The three different types of motion: uniform motion, simple harmonic motion, and uniform acceleration and retardation. So you really need to know all those three different types of motion that you can get in a CAM drawing. Step 1 needs to always be to read the instructions. So take a moment and please read the instructions. After you've read the instructions, I'd like to get some marks on the board. So I want to do some of the basic things that can get me some marks straight away. For example, putting in the label for the displacement graph, drawing the camshaft and hatching the camshaft, and drawing the follower. There I have done my printing between the train tracks, so block letter capitals nice and neatly. I've drawn my camshaft with a diameter of 20, radius of 10, and put in the hatching, and I've drawn in my follower. Now what I notice about the position of the follower here is that it is at a very high position, and in my opinion, if they've drawn the graph here, we're going to probably find that this follower is going to be falling. So if we went through the information here, it's telling us that from 0 to 60, and again what you could do is draw a little bit of a small point here. So it says here from 0 to 60, it drops 60, then it's at rest, then it drops 34, then it's at rest, and then returns to its original position. Okay, so there's given me a bit of an idea of what it's going to look like, which makes sense about why this follower is so high. So again, if you're a little bit unsure about things, maybe when you read through this information, do a little bit of a drawing, and it'll give you a bit of an idea what to expect with your displacement graph and what's going to happen with your follower. So let's get on to doing the drawing. 0 to 60, the follower drops 20. So at 60, I'm going to mark off 20. That's uniform motion. So there's that straight line, and I can draw that straight in. 60 to 105, the follower is at rest. Now 105 is in between measurements, and 105 is 90 plus 15. Our divisions are 30, so we need to find half of 30, which is 15, and if we divide our scale here, that would mean 4 for every 15 degrees. So I need to now find 4 millimeters away from 90. Put that little line in, and here is that dwell period where the follower isn't doing anything. From 105 to 195, the follower drops 34 millimeters with simple harmonic motion. Now with simple harmonic motion, the S part stands for circle in Afrikaans, which means we're going to use the circle to find divisions. And with the circle, we are looking generally for 6 divisions, because that gives us our half of the circle, and 6 points at 30-degree increments. So if we've got 6 height measurements, we need to have 6 vertical measurements. And if I measure across here, I need to go to 195. So if I add in extra points, I will get 6 divisions, meaning this is 0, 1, 2, 3, 4, 5, and 195 will be 6. So let's put in those extra 4 millimeter divisions to get our extra vertical divisions. So each of those, I've included a 4 millimeter division. Okay, this is a construction line. Hopefully your construction line is also relatively light. Now this remaining distance, when I check, is that distance of 34. So I've then just marked off 17, and I've drawn a semicircle. Again, if you've got your circle stencil, a 34 diameter circle is usually on a circle stencil, so you can use that to draw your semicircle. I'm now going to make my 30-degree divisions on this line. So in the circle. So I've put in my circle and my divisions. Now it's up to you how you want to label them. You could match the 0, 1 to 6 labeling, or you could put in the degrees that you wanted. So this would have been 0 and 105. This would be 1 and 120. So if you did the same thing like the angles, this would have been 105, this would have been 120, this needs to go to 135, this needs to go to 150, this will go to 165, this will go to 180, and this will go to 195. Or you could just label them as it is with the numbers. So 0, 1, 2, 3, 4, 5, 6. It's up to you which way suits you best and which way you'll remember best. What I'm going to do now is project the lines across. So my 0 point, there is my 0 point. I now need to take the 120 or 0.1 and project it to 120. Here is line 2, or at 135, and I project the next height to that point. My next height is at 150, or line 3. There's 150 and line 3. As you'll see, I'll make a little dot to see where I need to make my mark. And there's 180 and 195. Now, when I join them up, the middle 3 lines should be on a straight line. So that's your test for your accuracy. If they don't, you've made a problem, and you need to just go and check and see what's happened. And then we curve these last ones in. Curve. And there is my simple harmonic motion. From 190 to 240, it's at rest. So there is our rest aspect. Now from 240 to 360, it goes up to the original position. So there's the original corner it needs to go up to, and we need to use uniform acceleration and retardation. Now again, we're trying to find 6 divisions. Now if we check that, so there's 0, 1, 2, 3, 4. Okay, that doesn't work, and that's going to mean we're going to do the line division method just to get 6 points in this little space. As this is going to travel across 4 divisions, what we need to do is we need to have 4 equal vertical divisions. This involves us using the line division method. So what I'm going to do is draw a random line, and I'm going to put in 4 equal measurements of 10. So there's 4, 3, 2, 1. And now what we do is we line up the last line to the end point at the top of the shape, get that angle, line up our set squares together, then we'll slide this one down so that we can draw a parallel line and there are those 4 points. Now the middle line is here at point 2. And what I need to do is transfer these height measurements across to that center line. Now a good test for accuracy is to draw in the diagonal from the start corner to the end corner. So we were going from 240 up to 360. And that's your center there. Now to find the other points, it's a little bit like the same numbering here. So what I would do is the following. I'm starting at the bottom here. This will be line 0, 1, 2, 3, and 4. This is my height, 0, 1, 2, 3, 4. And now we sort of do a bit of a matchup. So if I take height 0 to this corner here, that gives me my start point. Now if I go to from my corner to height 1, where it intersects the vertical line 1, gives me my point. Now point 2 we've already got because it's the center one. Now we come to the other side. This is the retardation, slowing down side, and I go from corner 3, from height 3 to the corner. I draw that line, and where it hits my vertical line gives me my point. Now 4 and 4 intersect at that corner. Okay, so again, often I feel that these lines are fairly straight, and then I'm going to curve that in to slope into the edge of that. And there I have my simple harmonic motion, where I use the circle divisions to transfer height measurements. In simple uniform acceleration and retardation, we need to divide the heights into equal measurements to the amount of points that we've got on the horizontal side there. I'm going to start putting in my divisions here for all the different points that I'm going to need to do. I'm going to label my direction of rotation as well. Now there are my basic divisions. I've put in my direction of rotation anti-clockwise. Now the important thing when we do the labeling, two things. Where the follower is always 0. Now, because the shaft is rotating anti-clockwise, we need to label clockwise. Because the shaft is rotating anti-clockwise, it causes the cam to rotate clockwise, so our labeling must be clockwise. Okay, so there we have the labels. I'm going to put in the 15-degree splits that I need to find from 105, 135, and 165. I've put in those extra divisions that I needed here at 15-degree angles. You can use your protractor, or if you work around with your two set squares together, you'll be able to get those 15-degree angles that you need as well. My next step is going to project my height divisions to the vertical line. Remember, you always need to project to the vertical line, and then take a compass and rotate your measurements to the different angular divisions. As you can see, I've projected my lines across to the vertical line, and I'm now going to take my compass and project them. So point 0 is obviously the top of the follower, so that's good news. We've got that point already. Here is 30. There's my arc. Line up 60. Now again, you can draw your arc all the way around. To save time though, you might just hit it at the point of 60, and it's going from 60 to 105. So that should give you that line that is actually an arc. Now another way we could speed up and save a little bit of time is not projecting our lines all the way. So there was 105, my next point here is 120. So what I do is I line my pencil up with that point, project it across, and there is 105. Here is my next point. Sorry, that was 120. Here is my next height at 135. Project that, needs to go to 135. Here's my next height at 150, and just mark it there, needs to go to 150. I'll put the labels there so I know where I need to draw the arc to. Here is 165. There's 180, and the lowest point is at 195. Now I'm going to stop there. I don't want to clutter that up too much at this stage, so I'm going to transfer my arcs now. So I'm going to my next point here at 120. So I line up 120 again. I'm just going to make a mark at 120. Next point at 135. Make a mark at 135. Bring it down to 150. Make my mark at 150. $165. 180. Smallest one at 195. Now 195 goes all the way around until 240. So I'm going to draw that as an arc. So there's 195 going around to 240 as that arc. So let's do the last few points. So here is 270. If you're projecting your lines, just make sure they're light enough. There's 300. And 330. Take those points across quickly. So line up 270. $300 coming up. And 330. And there are all my points plotted for joining up. You can join them with a French curve. A flexi curve would be very nice. Get you a nice good line, And unfortunately, if you don't have one, try and draw it as neatly and as smoothly as possible freehand. There is my cam and the LOCI, and it will be good to just go over the mark rubric to see if we've done everything that we need to. Have we done the graph? Yes, we've done the graph. Have we labeled the graph? Yes. Have we plotted our points? Well, we've taken them across and transferred them around. Have we done the locus? Yes, the shape of our cam profile. Did we do any construction? Yes, we've put in our divisions. We've done the construction for our uniform acceleration and retardation, and our construction here for the simple harmonic motion. Have we done our shaft and hatched it? Yes. Have we done the direction? Yes. And we've done our divisions? Yes. Have we drawn in the follower? Yes. So it looks like we've covered everything we need here, and hopefully we will get a cracking mark.